Hello, I am Anushka Srivastav, and I will be presenting research on sea surface temperature anomalies in relation to tropical storm events, which I conducted as part of my honors thesis in my undergrad. I was initially drawn to this by the apparent emergence of increased precipitation associated with tropical storm events. Hurricane Harvey, Maria, and Florence dropped massive amounts of precipitation, and I was curious to see if there were any links to the changing climate. I chose to narrow my scope of research to events that impacted New Jersey, and using a grid off the coast of New Jersey to examine sea surface temperature and sea surface temperature anomalies. Using this data, I was able to compile a list of 73 storms affecting New Jersey between 1982 and 2020, their precipitation, and the average sea surface temperature and sea surface temperature anomaly around the time of the event. In order to source and clean data, I applied the Safer-Simpson classification and recalculated weighted average precipitation for each storm. The storms are color-coded to signify category upon impact to New Jersey, seen in Table 2. Precipitation records from 14 stations were averaged to calculate weighted average precipitation for each of the 73 events. Demonstrates that in order to deposit 50 millimeters or 100 millimeters of precipitation, a system needs to typically be within 240 kilometers or 160 kilometer radius of the New Jersey centroid respectively. Figures seen in 4 and 5. Sea surface temperature and sea surface temperature anomalies are of particular interest in the study as they are evaluated with regard to precipitation amounts associated with storms. On average, positive sea surface temperature anomalies were found for all storms, no matter what month in which they occurred, seen in Figures 6 and 7. In the end, I was able to calculate a slight upward trajectory, which indicates an overall ocean warming within the region, seen in Figure 8. And while there is a significant correlation between weighted average precipitation and sea surface temperature anomaly, I got an R of 0.87, the trend is weak for the last 5 years of the data, which you can see in Figure 9. This may reflect the weakening of the circulation response to sea surface temperature anomalies, which is closely tied to the increased atmospheric stability under global warming. Study results tend to agree with the global review that suggests the changes in planetary circulation regimes are linked to global sea surface temperature anomalies. It further suggests that the general weakening of the atmospheric circulation will offset some of the enhancements of the tropical rainfall response of these sea surface temperature models as a result of global warming. Looking forward, additional grid boxes could be compiled along the storm track, as well as further examination of other storm systems such as Western Pacific Ocean, Northern Indian Ocean, and the U.S. Atlantic coast and Gulf, and in the Caribbean, to help understand sea surface temperature and sea surface temperature anomalies in relation to precipitation. Thank you for your time.